Good afternoon, everyone. Here is Julien Cellier, Managing Director of CompoSIDE, and I'm here together with Jonathan.
Hello, everyone.
With one of our application engineers. We still have quite a number of attendees joining. So to the few that are already there, welcome in this webinar, and we'll try to wait 1 or 2 minutes, not more, for people who are slightly late. Overall, we've got quite a diverse list of registrants for today's webinar. It ranges from aerospace engineers to architects, naval architects, structural engineers, for all sorts of application in marine, in civil, obviously aerospace I mentioned already, and so. Okay, so I think now we are ready to start. So during this webinar we'll look at converting metallic structures to composites and subsequent laminate optimization. The objective of today are first a brief introduction to our case study, then an introduction to CompoSIDE and CMDB, the CompoSIDE material database. In contrary to our previous webinars, and to make sure that we will pick up the first question and answer session for CMDB specifically before John takes on the wheel to get us into the live demo on the case study, and then we'll have a final question and answer session. Before we get started, I'd like to remind everyone or make outline our subscription model. CompoSIDE is a software as a service, so it has a SaaS license rather than an on-premises license in the form of quarterly or annual subscription. You can see on your screen 3 different subscription levels depending on the size of your team, and obviously we have a tendency to recommend to start with a baseline professional edition, and then as you grow your usage and grow your competencies within CompoSIDE and adapt your workflow, get more proficient, then you can look at upgrading to the upper subscriptions. The baseline package is an annual subscription price, and then the CMDB Addon, which we will discuss in the first part of the webinar, is an addition to this subscription to get access to the fully comprehensive set of data. Okay. So John, tell us a bit about the case studies that we'll be looking at today.
Okay, so to provide a practical example for the webinar today, we're going to look at a 6-meter radius segment of an architectural sphere. This is quite a common piece of work that a civil engineer would be designing. Currently it's made of aluminium alloy and it weighs just over 650 kilos. The goal of this is to analyze the feasibility of the structure whilst using composites, whilst retaining the same amount of stiffness, so the deflection in the panel and the beams. So how would you approach this problem efficiently with a minimal knowledge of composites? First we're going to run through a few questions to get you thinking about how you'd approach it and how CompoSIDE can help you with that. So let me introduce the main questions. What technology and materials are to select and achieve a lighter solution? If you're using a metallic structure, you may be asked to reduce the weight or improve the structural performance of your products. Or you may simply want to offer a premium product for some of your clients. Composites are a very, very straightforward way to achieve these goals. One approach is quite widely used in the market is to take the total material weight of a structure and ask the pricing of similar quantities of carbon or glass, otherwise known as the black metal approach. The outcome is also almost certainly not favourable to composites, and is also wrong for the vast majority of cases. The first questions are generally related to business case. It needs to make sense from a business and a product point of view. How much weight can I save? How stronger or stiffer will the resulting structure be? And the obvious, how much more is it going to cost? So there are a few rule of thumbs you may take, or from examples outside, but how reliable are they? Today we want to show you that you can answer these questions yourself with greater accuracy with CompoSIDE and just a couple of engineering bits. So back to those questions, what technology and materials to select and achieve a lighter solution, how to assess my composite structural concept, and what are the associated material quantities. So the first rule that most metal to composite guys have are which material should I use, where can I get the properties, how should I orientate my fibres or plies, how do I ensure the compliance of my laminate, is it going to pass my load cases, are there opportunities to optimize, and again on top of that, how do I optimize it? I don't necessarily have the knowledge to be a composite designer, but CompoSIDE can help you with that. And finally, how can I compare total material costs? So the first question, which materials? Composites are very complicated in terms of their makeup. So you've got a fibre, which are mixed with a resin to make a ply, and then you've got cores and adhesives, and this is all linked with the manufacturing process. So you've got 3, 4, 5 different ways of combining different materials to get different properties. And then the process, so it could be wet lamination to pre-preg. These massively change the strength and stiffness properties of my materials and my final products. So how do I know which one it's going to be and which one is most suitable for my product? Should I do some testing? So big aerospace companies spend millions on material testing programs, post-processing qualifications. Is this the only way? I'll let Julian run through the testing processes with you.
Okay, so testing costs, that's one very common starting point, but as you can see on this slide, there are a number of costs, and it's generally a high cost associated with it. So here we just present an overview of what are the costs of characterizing one material. You need to source your materials, make your coupons, that's going to cost you around a figure of €1,500. Then do a set of testing to characterize the material statistically, which is another around €6,500. And finally, if given the application you're looking at, you need a set of fatigue data, you're looking at, for testing up to 5 million cycles at a coupon level, to about a bill of €45,000. As John mentioned, aerospace qualification can be even more extensive depending on its all risk versus reward. Okay. The baseline to start a design is really to have a set of static properties. So we'll see how we can, how we believe the CMDB add-on addresses these challenges. Because we don't, come back one slide, we do not really think that we need to spend many thousands of euros before starting designing with composites. It's a bit like, you know, it's interesting, but, you know, first pay your entry ticket, and it's actually quite a pricey one because in most cases you look at different process, material combination, type of fabrics, and very quickly that's an exponential, the level of complication is exponentially growing. So here you can see the testing pyramid, and CMDB Addon is really a package to address the mechanical properties of laminates at coupon level, okay, which is a starting point. The data that is available within the CMDB Addon is at the level of characteristic values. So it means data that is fit for design, okay. So how can the CMDB add-on reduce the material testing cost? Basically, it's a consolidated set of data enabling a quick and easy start with your project. So you can assess, irrespective of the the mechanical properties of, or the type of product, the viability of composite as a solution, then in turn material testing becomes a validation rather than an investigation, which saves you a lot of time, a lot of money, as well as a lot of hassle to get all those costs approved, signed off, depending on the type of organization you work in. Okay? So, John, if you can run us through the basics of CMDBs, that would be really useful.
Okay, so as I mentioned earlier, composites are a composite of materials, process, and engineering. From this, composites require a high degree of integration compared to conventional materials and construction. Composites are also quite sensitive to data quality and ability to use the data efficiently. So for this, we've developed CompoSIDE quite efficiently, so everything's linked together, all the process, engineering, and materials are linked together, along with a basic set of materials which you would get with your trial subscription, and the CMDB add-on, which is quite an extensive list of materials, not just composites, but metallics, woods, adhesives, etc. So materials are covered by CMDB. This is where all of our data is stored, and we can compare, analyze, and check and share our data within there. Our processing is mainly to do with PlyGen, but this also links up with CMDB and the materials because that gives us our strength, our weight, our stiffness properties. And then we have our engineering modules such as laminar space, section space, and FE space, which gives us our classical laminate theory, our 2D analysis, and our 3D analysis. So within CMDB, you can use a reference material to fill in the gaps. So for manual materials, you can input your test data. You can use reference materials to fill in the gaps if you've got any missing data fields. And you can also, as Julian has mentioned, use the CMDB add-on materials, which is another plugin for your CompoSIDE environment. You can also create materials, so a PlyGen material uses micromechanics to create stiffness and strength properties based on a fibre, a matrix, and a processing type. And you can also create small laminates, so layered materials using classical laminate theory to create such as multi-axial plies, quadraxials out of a set of UDs if you only have the UD testing data. Within CMDB, as I mentioned, you can also do a lot of post-processing. You can export the properties for calculation both to FEA and to Excel. You can create material selections depending on different groups and how you want to compare or use your materials later on in the software. Again, you've got data comparison, scatter plots, very visual ways of comparing and checking data. And then you can also export and import your materials directly into CompoSIDE and share it directly with all of your colleagues. CompoSIDE is a web-based tool, so as long as you have internet connection and a browser, you can access all of your data anywhere in the world. So within CMDB, you have material libraries. My company materials, so this is your specific material list. You can filter this out and polish it, or you can have someone to look after that and nurture that library. We have the CS material library, which is the CMDB add-on. This is over 1,200 materials, which you would get with that plugin. And then you have your active project materials. So within CompoSIDE, it works on project-based design, so you don't have all of your data in one project. You can drag and drop it into your project materials and filter it out as you go along. And then you can create material selections from those project materials to filter it down even further. As you can see here, I've got adhesives, carbons, and cores. But you have the option to organize it however you wish.
Okay, so what we've mentioned a few times CMDB add-on, but what do we really get? So brief technical overview, we've mentioned it, material data fit for design, characteristic values. Okay, we don't have too many material manufacturers today on the call, so I can say it, but usually the data sheets are more marketing-wise than fit for engineers. Industry-proven values, so it's this material data has been used across a wide range of industrial projects which successfully passed certification, and it's expected that most of the supply chain would fit within those data, while the data is not over-conservative. It's very easy to make sure your data is safe, but then you'll end up with a very heavy part. We would expect that we would expect to, after a qualification of a material, to have a variance of plus and minus 5% compared to the data that is there. So it's quite a robust set of data that you can base some of your key decisions for your business upon. Full data set, so it's very much plug and play for your FEA package for those who manipulate the likes of Nastran, ANSYS, or the HyperWorks suite. And transferable, we can export materials and laminates outside CompoSIDE to the mainstream FE packages. So, let's talk numbers. CMDB 12 add-on, 1277 materials, fibers, resin, plies, adhesives, cores, metals, wood and plywoods. We'll focus on the plies and core in today's webinar, but these other material groups are there because we believe the designers and the composite designers really need to have access to the full range and potential that the industry offers. The cores, 212 core material within our CMDB add-on. Interestingly, the cores is the only one where we have, let's say, specific references to material manufacturers. You can see that there's a big 3A logo here. 3A has been sponsoring this year our webinars, therefore enabling to do more webinars this year, which is great. And they are one of the suppliers, but there are also all the other common options. The reason for the core material to be reference specific is that this market is dominated by 4 larger companies, and the engineer specifies the references. Quite a lot of different types of foams ranging from PVC, PETs, SAN, PMI, honeycombs, and so a bit for everyone there. On the plies, there we get really in the heart of the level of complexity of the composites. There is not really standard. There are standards for testing properties, but not really standards when it comes to the material itself, to the composite material, after it's cured with the fabric or the fiber mixed with the resin. So one type of material is basically one test campaign. The graph you can see below shows the main parameters that will affect a ply property. So you've got the group at the fiber level with the fiber type, the fiber grade. For example, there are different types of glass, of carbons. The fabric type, is it a woven, is it a stitched product, and also the fiber sizing, which makes the fiber compatible with the chemical agents of the resin, enabling the composite to be formed. Then you've got the resin that has its level of complexity, and finally the manufacturing process, and basically the combination of those 3 key group, fiber, resin, process, is what will determine your ply properties and how much of a given material you need for your application. In CMDB, due to this complexity where you saw we end up with about 890 plies with 9 different fiber types, 7 fabrics type. About 95 to 98% of the composite application are built with products that are referenced within CMDB, okay? With a mix of unidirectional wovens, biax, triax, quadrax, mats, and stack-ups that are commonly used in the polyester-built composite structures with mat combined with multi-axials. 10 different types of matrices, including thermoplastics, and 8 different manufacturing methods. Combine that all together, you've got a lot of plies and a lot of data to deal with. Here you have a snapshot of a scatter plot where we basically selected all the combos that we have, combination of chopped strand mat with multi-axials to show the spread of density versus tensile modulus. So there's quite a range of materials that can be chosen. And if this is not enough, because for some people it's never enough, we have PlyGen. PlyGen allows you to build your own material based on a fiber and a resin type. And then you've got a quite a cool functionality, is that you can use some of your reference material in the database for all the strengths related properties. And then you can use this material across your design. Last word of CMDB, obviously 890 plies, you need to be able to categorize it in a nice and easy way for yourself first, but also for the people you're going to communicate with. So here you've got an overview of the nomenclature for CMDB, showing the fabric type, fiber grade, reinforcement weight, matrix type, and manufacturing process. Okay. So we reach our first break of the session, and we would like to maybe ask you if you've got any question relating to the CMDB add-on, to please put it forward. And also, we know it's early afternoon here in England, mid-afternoon in mainland Europe, and it's always a difficult time. We are all digesting, we had a good meal, and I would like to make sure that you've got maximum attention before John digs into the live demo. So if we give you 30 seconds to put your questions as to what you would like to know further about CMDB, and then we'll go into the live demonstration. Okay, so the first question is whether we qualified fully 890 materials. Let's be honest, we didn't spend 10 million or 15 million euros for a material database. However, the first point is that working out stiffnesses of a ply, once you understand and have a few references with the manufacturing process, is about quantifying the fiber volume fraction associated with that process, that type of resin, that type of product, and avoid content. So getting the stiffnesses right is, let's say, the easy part of the job. Now, when it comes to the strength, which is the key element, because a lot of our applications that we design are strength-driven. This is a mix of, let's say, point testing acquired upon experience, sharing from the material manufacturers to provide us with references, and finally, good engineering judgment. So if questioned about the material properties within CMDB, we believe this is a perfect set of material to start a design to evaluate whether the suitability of a material for an application. If you decide to go further and manufacture it, instead of testing 10 material during a screening element, you will have only to test one material and validate the design arrival. We are very confident as to the validity of the data in there for design purposes. Okay. Second question, is the material data kept up to date and added to? Yes, that's one of the beauty of CompoSIDE being a web-based software, is that updates are seamless, and we have an ongoing maintenance program on the CMDB data. And it's actually a program that is very much driven by you, the users. If there are more materials that you need added, we will add it, we will look into it. If you have comments, we'll happily take your comments on that. So yes, it's very much a live database that is growing as time passes. Okay, I can see there are more questions, but maybe we move on to the live demo now, and we'll pick those up at the end of the session.
Okay, so let's design. We've seen this slide before. So composites require a high degree of integration compared to conventional materials. Data quality and ability to use the data efficiently is very important. And the connection between materials process and engineering requires a lot of integration. So as I mentioned earlier, we have CMDB for our materials, laminar space for our laminates, section space for our 2D sections, and FE space for our 3D panels, beams, etc. And then we round this all off with PlyGen, where it collects all of the material data, puts it in quantities, applies factors based on the type of manufacturing, so you can get a manufacturing bill of materials and an engineering bill of materials from one click. So the case study again is this aluminium alloy 6-meter radius architectural sphere segments, 650 kilos roughly, and we need to reduce the weight while retaining stiffness. So the requirements. Structure is to withstand gravity and wind loading, so it's just a pressure and a gravity loading. And our maximum deflection is 10 millimeters, ensuring sufficient strength. So how would we go about this in CompoSIDE? So our baseline design analysis, CMDB, we select our materials. We have aluminium, we have carbon fibres, we have glass fibres, and different matrix and processing types within CMDB. We then use this to create 2D sections and then create a 3D model using these sections and shells. So let's jump into CompoSIDE. For those of you who aren't familiar with this, this is the home screen. You can see that I'm using it in my browser. And the general workflow is from left to right. So within here I have my projects, which I've set up in project space. You can assign users to specific projects. You can add projects. You can add different factors, safety factors, bill of material settings within here. And then we have CMDB. So let's start in CMDB. And you can see that in here I have my active project materials. I have my CS material library, which is the add-on, and I have my basic list of company materials. So if I have my aluminium material, and I want to compare it to, for example, a unidirectional carbon, but I'm not sure about the modulus. I know it wants to be epoxy and it's going to be a prepreg. So what I can do is I can select these materials, so a high modulus, an intermediate modulus, and a standard modulus. And if I right click, I can compare these materials, have a look at the calculation properties for calculation, export it to Excel if you're working with Excel, or generate a very visual scatter plot. So let's do that. And we'll have a look for density versus stiffness. So let's go for the tensile modulus. And we can see very quickly that, that obviously the high modulus is a lot stiffer than the intermediate modulus and the standard modulus and the aluminium down here. So it's a lot heavier than the carbon fibers. So if you're very new to composites or materials in general, you can select as many materials as you want and compare them very visually by hovering over and having a look. What I can also do is I can also export this list to a suite of engineering tools, so Nastran, OptiStruct, ACP, or Excel. And also I have a material selection here. So in here I have my carbon fibers, where if I have a list in my project materials of maybe 50 different materials and I want to choose a list of 3, 4, 5 materials, I can do that very easily. And I can go do bulk calculations, so having a look at the properties and the scatter plot, export to ANSYS, Nastran, OptiStruct, etc. So for now I've used a very basic quadriaxial standard modulus, 400 gram vacuum infused ply for my project, but we're on the baseline. So what I've done in laminar space is I have created a laminate for my aluminium panel. I have an aluminium ply, which is 4 millimeters thick, and here I can have a look at the engineering constants, so my in-plane and out-plane stiffnesses, my allowables, so my strength values, my sandwich stability obviously doesn't apply to aluminium. I can also apply loads, thermal in-plane loads, out-of-plane loads, bending moments, etc. in here. So if I was just interested in comparing materials just of a basic 1 millimeter strip, I can do that very easily within here by creating a stacker. Okay, so the next step would be to create a 2D section within section space. I have an aluminium section, so let's just open this up. And this you can create geometry by importing it from a DXF. We also have a few tools to help you create geometries very easily. So you can create a geometry from template, which you can select a series of standard sections, so C-beam, L-flange, hollow rectangular, and I-beam. And once you put these in, it's all parametric, so you can update this very, very quickly, add materials to different sections or all of the section as you need. In here you can also have a look at the section properties, so calculate this very quickly. If you're working with a spreadsheet or similar, you can export these directly to Excel. These are just our stiffnesses, our second moments of areas, etc.
I have a question for you, John. It's a very simple section. How complicated a section can you deal with in section space?
Very complex. You can work from a basic beam to, for example, for the marine customers out there, you can take a midship section and apply a bending moment to it from a hogging or sagging load. We can also apply aerofoil sections if you're working with wings or blades or things like that.
Okay.
We can create an airfoil. So this is a standard NACA series airfoil, and we can play around with the parameters here and scale it up based on the length.
Okay.
You can also import it from a file. So
okay.
There's quite a few functions here. You're welcome. Okay, so this is my basic aluminium section. Again, I've gone for a 4 millimeters thick section, just to keep it simple, just to get a baseline design, so I can save and close. Now this is going to be used later on in FE space. This is linked with all the other modules. So once I've done it in here, I can then move on to FE space. So let's do that. Let's jump into FE space. So I have a few different models in here where I've been playing around before the webinar. I have a product which is called a cladding panel. You can create different projects within product. Yeah. So let's have a look at the baseline design. Here, so this geometry was generated using a sketch and then revolved a few times, and you can see that I've added my beam sections to each of these lines here, which is how I want to build it. You can also import geometry from step. We work with step geometry imports. You can also create a beam from templates. So as you saw in my section, I can create that into a 3D shape by a few clicks. I can apply a length, assign that property to the line, and then I have a basic, quick 3D model of my beam. We also have a shell template tool. So in here I can select a curved or flat panel, just put in the radius, length, width, laminate, loads, and boundary conditions, which is very, very good if you're doing a quick buckling check or a quick bending check for your panel, which you might do by hand now, but it might be a bit quicker to do it this way. Okay, so what I've done is I've assigned my laminates to this as a shell, and you can see I have my stack here, which is very basic for the aluminium. It's only 4 millimeters thick, but this is linked up with my laminar space. Laminates. Okay, so I've meshed it and calculated it, and when I do that, it sends off a task to the server. Usually it takes around 10 seconds, maybe 15 seconds if it's feeling a bit slow. and then it will give you your task. So this is stored in the tree. You can lock it, you can rename it if you want to save these particular results.
So basically, so far you've used CompoSIDE to design aluminium.
Correct. Yeah. Yeah. So in here I can have a look at my displacement results. I can have a look at my applied forces, my reactions. I can also have a look at my shell element results, so my strains, for each individual ply or as a stack. My internal forces, internal moments. There's a lot of detail in here. I won't go into it now because it might take a while. But there's a lot of functionalities that you'll be used to working with. The nomenclature is all the same, and it's fairly easy to pick up. I can also just do a very quick reserve factor check. So if I set my failure type, so minimum fibre, resin shear, and hit calculate, it will just give me my reserve factors for my shell. Usually will. I don't know what's going on, but it's metals. Yeah, so there we go. So 1.25, perfect. Thanks, Julian.
My pleasure.
Okay, so we have our baseline design. Let's go back to the presentation. So what I did was the first round was I converted this to composite. So I selected my materials in CMDB, replaced the materials in my 2D section, and then replaced the laminate in FE space. So let's go through a laminate creation live. So let's jump into laminate space. And I've got a basic single skin panel here, which I know passes, and this gives me a weight of 396 kilos, which is a weight saving of 40%. But I want to remove my stiffness from the middle of the panel, and I want to make it a sandwich panel. So back into here. So to create a new laminate, create laminate family. Let's call this sandwich panel.
So now you're working in laminar space.
In laminar space, yeah. I've selected all my materials. I've dragged them into my project materials, created a selection if I needed to. And in here, if you're used to working with composites, it's very friendly. You can add a ply, add a core, you can reorder them. So I'm going to add a few plies. You can see that I have my selection here. Well, I've got my standalone materials, so I haven't put these into a selection. I'm going to use quadriaxial carbon, and I'm going to choose 3 plies, and I can orientate them as I wish. So then I need to add a core. I'm going to use T92, which is a 3A foam, an 80 kilo PET foam. Try and keep the cost down a little bit. And let's go for a, say, 45 millimeters thickness, because I want a fairly chunky panel. If it's a 6 meter radius, it's not a small panel. Now, instead of creating the other skin, I can use a sequence type. So symmetric odd is probably going to be the best one for me. So if I change anything in the outer skin, it's going to automatically mirror into the inner skin. So I only have to change the plies once. Or if I want to change each skin individually, I can hit convert, and it will just make it individual and break the link. If I've got a lot of plies, the list is very long. CompoSIDE can work with quite a long list of materials. I can just compress the stack up, and it will show me a very compressed laminate. And if I'm looking at the weight, just initially, I'm going to have a look at the thickness, the weight. This is with resin, or I can just have a look at the reinforcement weight. So if I'm comparing it between 2 different manufacturing types, and I want to keep the reinforcement weight the same, this is a very good way of checking. Okay, so if I save and close, it loads for a bit. So what it's doing is it's calculating all of the engineering constants, all of the allowable bending moments. In here you can see I've got my allowable bending moments for each direction and each failure type, so there's a lot of data in here. These are usually your hand calcs, so things that you note down in your notepad, automatically calculated here very quickly. And then I can also have a look at my sandwich stability of here, check if it's going to buckle. If I know my critical load, stress or strain, very quick calculation of if it's okay. So I'm going to keep the same section as I did before within section space. It's going to be a single skin quadriaxial section. We didn't show that, but it's been created to get the cladding panel. And I'm going to just duplicate my carbon version. It's exactly the same as the aluminium one, just a different material. And we're going to open this up. Okay. So there's no beam there anyway. So here you can see that there's no beam, and I can very quickly just replace this material. Okay, it's already been done. But if I was to do this from scratch, I could remove my laminate family, add laminate family, and select the one we just created, the sandwich panel, and then hit add. And you can see that I have a little pencil here and a laminar space here. So instead of going out of FE space, jumping into laminar space, I can just click this button here. It will bring me into my laminar space module. I can play with the laminate, add a few plies, remove a few plies, reorder, increase the thickness of the core, etc. And then save and close. And it'll update the laminate automatically. You can see I've got a little warning sign saying your laminates may have changed. Please recalculate. So if I mesh this again, it would just take the latest laminate, and because I duplicated this from before, it will have the same boundary conditions, loads, which is what I worked with before. It's just a working pressure, and there's a gravity load applied to this as well. So I calculate, and you'll see it'll fly off to the server, and it'll be calculating in the window in the tree on the left here. If I wanted to, I could exit FE space, and it will just go in the background. Okay, 11 seconds is going a bit slow. So we're at 10.85 millimeters deflection. That's pretty good. I'm going to leave it there. I'm pretty happy with that. Okay, so back to the presentation. I did a carbon fiber version, so it's single skin, 396 kilos. Again, weight saving of 40%. And then we had a look at optimizing the laminate. So what we did here is we removed the beam sections in the middle and then made it a sandwich construction. So the process for that is select the materials. We did that before. Optimize the laminate. So instead of optimizing, we created a new laminate and then just reapplied it to our section. And then that gave us an overall weight of 314 kilos. So that saved another 8% of weight. But as you can see, it could do with a bit more further optimization using the same process. And there's one last task within CompoSIDE which is very useful.
So before you go to that task, so basically what you've done, you had a design in aluminium.
Yeah.
And you've basically using the same model, basically swapped the aluminium for a single skin option, keeping the intermediate stringers, yeah. And also then looking at a sandwich solution just by swapping the laminate, using all the same analysis setup and jumping in and out of FE space and interacting with laminar space.
Correct, yeah.
Okay.
So if I want to generate a bill of materials, which I mentioned in the beginning, this is the final step. Usually your boss asks you for a report, or you have to give it out to a customer as a deliverable. Instead of taking all of that data and putting it in a spreadsheet, applying your manufacturing values and core offcuts, ply offcuts, adding all of that, what we can do is go into PlyGen, and then we can generate a bill of materials. So what it's doing is it's grabbing all of the data from our modules, and we can play around with this. So you see I have a few different panels in here, and if I just have a look at one of them, I can see I have 607 square meters of my quadriaxial as a designed area. If I was to send this to a manufacturer, they would have a certain amount of offcut, they would have overlap factors for your plies, etc. So this will bump up the area to 682.9. Now this is specific to each manufacturing type. it's specific to each type of material. So, for example, the unidirectional wouldn't have the same off-cut values factor as a quadriaxial. And this is all calculated automatically. What CompoSIDE does is it gives you a basic set of values, which is what we've been using for years. But if you have specific manufacturing factors, overlap, usage and wastage factors, so let's have a look in here. You can put these in if you've got optimized values. So if, for example, if your fabric offcut is for infusion is not 7, maybe you're using a machine to cut all the plies, and you've optimized it to be 5%, you can update this as a project or as a whole environment. So anything that's done at an environment level, it can be penetrated to all of your designers, engineers, if you're from manufacturing.
So basically, with those settings, you control the parameters and the factors that make a bill of material an engineering bill of material or a manufacturing bill of material, and the users can tweak it to the specifics of their process.
Exactly.
Okay.
Okay. So let's try to provide a short summary of what we've seen today. So CompoSIDE allows for a very efficient and comprehensive workflow within the design and analysis of both metallic and composite structures. A number of modules dedicated to each of the main design steps are available. So CMDB stores materials, plies, physical, mechanical properties, and it can be stored here and used within all projects automatically. Pricing information can be added and picked up from the later modules such as BOMGen for bill of materials generation, but we don't tend to give out the costs because they're very dependent on the type of industry and quantities that you order. Laminate Space is the laminate design module based on classical laminate theory, allows the design and evaluation of various laminates within the project. Section Space is the beam modeling and 2D sections drawing module within Section Space. You can import or generate 2D sections and perform a first principle analysis of your structures. FE Space is dedicated 3D modeling and FEA module. Import files or generate your own within FE Space. Automatically generate the mesh for linear, modal and buckling calculations. And then finally, BOMGen and Report Space is the automatic bill of materials generation module. Automatically calculates your weight, surfaces and costs for all the structures within your project. The integrated approach allows upstream modifications to be propagated downstream in the project, making it easy and quick to perform multiple optimization loops as we showed.
Okay, so what did we see in our case study, and what problems did we solve? So, well, you had plenty of choice of materials to look at the structure. You basically looked at three key elements: metal, quasi-isotropic, carbon laminate, and then a sandwich panel to try to make it in one piece rather than adding stiffness. CMDB Addon was quite useful to provide those material data. How to orient the fibers and the plies, obviously there can be more iterations, but you've demonstrated that CompoSIDE can perform quick optimization loop with its native workflows, whereas to do such iterations without CompoSIDE, you'll have to interface more than one time with Excel, back and forth out of different softwares, and it's not the most rewarding job for an engineer to do copy and paste between Excel spreadsheets and extracting data from one place and do it in the other one, unless you have the luxury to have a fully automated solution, but then there's a price obviously associated with that. Finally, you generated BOMGen and the material quantities. One note on the bill of material generator: this can be accessible in a PDF format and HTML format, summarizing the layups used across the part or the structures that was done, and manual elements such as bondings, because here we saw the segment of a sphere. If you imagine, let's say, a dome, based on these spheres, there will be a number of those parts together with joints, whether they are bolted joints or bonded joints. They can be as well documented in your bill of material. Okay. So we are nearing the end of this webinar. A short reminder about our subscriptions. Obviously here we present the commercial plans, but there are a few of you that are not yet registered, haven't gone through your trial. If you go on www.composite.com, you'll find an enormous button at the top of the landing page where there is an opportunity for 30 days trial in which we will help you as best as we can with our support and training materials to pick it up, to see what are your expectations with CompoSIDE and to help you to do the maximum with this great little product. Okay, I think we are ready for second and final question and answer. And we'll wait for a few questions from the attendees. First question, whether we can show briefly how to add a manual element on PlyGen.
Okay.
So, for example, a bonding.
Okay, so within here I've got my different products. I can add in as many groups as I wish. Every project has as a basic topology group or group, but you can add as many as you wish to this. First thing I'm going to do is I'm going to go into the topology and just keep one of these panels. So let's keep just the sandwich one. And if I save this, it'll update the data, and you can see that I've got two that have disappeared. Okay, so in my products I have just one set of data, and I have my my weights of my cores and plies. To create a manual element, right-click on the group and select bonding, reinforcement, or beam. The beam, you can create your own beams or use the same as in section space. So I can grab directly the one that I created and showed you earlier, or I can do it manually. So let's create a bonding. Bonding and reinforcements are fairly similar. Just two different types, just to differentiate them in the report. So I'm going to call this bonding. I'm going to set a length of, let's call it 6,000. And I'm going to have two of these, so there's going to be one each side of my panel. And in here, you can see that this is very similar to laminar space. At my top right, I have add ply, add core, add fillet, and homogeneous. So I'm going to first add a 2 mil thick adhesive paste, so just like that, and the width is going to be, let's go for 150 millimeters. Okay, and then I'm going to have an adhesive fillet, which is going to have a radius of around 20 millimeters. Okay, and then I'm going to add my plies as well, so I'm going to use an XC. Okay, I don't have any wet bonding plies, but I can easily just go back into the CMDB module and add them into my project materials. Okay, so I'm going to add 4 of these, and they're going to be at 45 degrees and let's say 300 millimeters wide. Okay, so very easily like that, I can adjust them or add remove plies and reorder them. And then I can save and close. And then this is automatically added to my material list. You'll see this added into here. I have my biax and I have my epoxy adhesive in here. And you can see that I have some material costs. My epoxy adhesive actually has costs. So if I assign the cost to all of my materials, then I would have a total material cost, which would mean my
give you a good indication.
Yeah.
Okay, great. Thank you very much. So we have time for one more question, and then I think everybody is quite busy, so we'd have to get on with stuffs. Apart from the bill of material, can any other cost be estimated? For example, the cost of energy for the process, cost of labor. Not at this stage, but this is something that we are looking at to develop BOMGen further and to be to develop further, basically. This is also an area we are looking at is to BOMGen is very much linked to the process, to the manufacturing, and basically people who manufacture with composites don't bother so much with all the design and engineering side. They need the information to be available, and with BOMGen there's a great platform to make that available. We are looking to develop further this part in the next year, and the elements like cost of energy for the process and cost of labor are definitely being looked at. Okay. I think that's it for today. The few questions that are unanswered, we'll get back to you individually after the webinar. We would like both John and myself to thank you very much for your attendance today. It was a very diverse crowd joining, and that's great. It shows that material properties are and design with composite is really a true challenge across industries, and we look forward to you guys registering and to help you in your journey to discover CompoSIDE, and hopefully demonstrating that this brings value within your day-to-day operation. Thank you very much.
Thank you, everyone.
Goodbye.